Okay, so here's our first focus activity of the last 6 weeks, and I took this off of that 2014 released exam as well. Okay, so we have ourselves a good old-fashioned scatter plot problem. Okay, so let's see what it says. Consider the following set of data, which is plotted on the scatter plot diagram below. So we have x's and y's. Looks like we got 1, 2, 3, 4, 5, 6, 7, 8 pairs. Okay. So what do we want to do? A, write down the coordinates of the mean point. What's another name that we called that? What's that? Heard someone say? No, the grand mean. Okay, there we go. Now, what I would probably do, because you'll notice this question's worth 2 marks. So a good rule of thumb is go ahead and show at least one line of work, okay, less than however many number of marks you have. So 2 marks, I want to show probably 1 line. 3 marks, I'd probably want to show 2. I would probably just go ahead and show something like this. Okay. Maybe you can just put it all as one coordinate, 2 plus 4 plus 7 plus 12 plus 4 plus 8 plus 9 plus 2, and then go ahead and divide that by 8. Okay, and then you can go ahead and do the same thing for the other one, again, just to show that you're getting where that value is coming from. But you'll notice the next question then wants me to go ahead and write down the value of R, so I would probably just go ahead and obtain all this from the calculator. Okay, so let's see here, which I do not have pulled up right now, and don't have a copy in front of me. Okay, so let's say I wanted to put in a set of data here. So I can go down here to my spreadsheet icon, or I can go to one and then click lists and spreadsheets. But we're going to go ahead and title these. Okay, and I don't have the paper in front of me. Can someone tell me what my X's are? 2. And 2. Okay. And then I can click Control 7, go back up to the top, and the Y values? And 7. Okay. Now I've got my data in. Okay. Does anybody remember the keystrokes that's going to allow me to find all that information, like not only the mean of the x's and the y's, the Pearson's correlation coefficient, the standard deviation, the box and whisker plot information, all that good stuff? Okay, so I'm going to go to Menu, Statistics, Stat Calculations. Okay, so is this 1 or 2? This is 2 because I am comparing x and y. Now, if it were a frequency list, just one set of data, then I would choose the 1, yes. So I'm going to go with 2 here. Now, this is where I'm going to go ahead and backspace that, put in the first title. Okay, choose the Y there. There is no frequency list here, and it looks like the results are going to show up in column D. Okay, so there we go. So right away I can see the mean of the Y's is going to be 13. If we were looking for standard deviation, did I take S of X or sigma X? Sigma X, okay. So we need 13 and 6. And you'll notice, okay, what I did on the focus activity is what they're going to be doing in the paper exams. If I come back over here, okay, they've got a little section for you to go ahead and put your answers, and then they'll have this contained within a larger area for you to show work if necessary. So I'm going to go ahead and put 613. Because if you've had a chance to look at the mark scheme, and how many people have? Okay, a few people. If you look at the mark scheme, one of the things that the grader is told, if the answer is correct, they're not even going to bother to look at your work. Okay. If it's 100% correct, they're going to give you the points and they're going to move on. If it's not right, then they'll go to look at your work and see if any partial points could be applied. Hey. I think it's not a bad idea. In fact, I'm going to go ahead and tell you something for B in just a second. Okay, so let's go ahead and find R. Let's see here. Okay, so there we go. So what would we go ahead and put? Oh, 9.5. I would probably go with 952. It doesn't say a certain number of decimal places, so I would go ahead and give them 3 sig figs. So 0.952. Yes, exactly. This thing disappeared. So 0.952. Okay. And so A and B, those are absolutely correct. So we're already going to get 4 marks for the problem, 6 total. So now C says draw the regression line for for y on x on the set of axes above. Okay, now remember these problems are progressive, so what I would do is probably include what point? I'd go ahead and include this one that we found, the 613. Because if you do go ahead and look at the mark scheme, they do have points tied to that. But I would probably even go a little further. They are going to be looking for accuracy. We'd want to have a really good idea about where the y-intercept is going to be. So I'm going to come on over here to the calculator. You remember how we can have the calculator determine that equation? Okay, so my data's in. I'm going to go home. Where do I go? Okay, it's down here at the bottom. Which one is it? Okay, data and statistics. Okay, we're going to go ahead and recreate the scatter plot in the calculator. So I'm going to choose this, or push enter. Okay, whatever you want. And then remember, this is the one time it just kind of throws those points on your screen. If you click tab, always choose what first? Always choose X, that first column, whatever you typed in. So it's highlighted. I'm going to push enter. Then I'm going to click tab, choose Y. And it should be giving me that scatter plot that's on my paper. So how do I get the line in the equation? Okay, so menu, analyze, and then show linear. There we go, A plus BX. Or MX plus B. I'm sorry. I chose the wrong one. There we go. So you'll notice we are going to have a place where it crosses the y-axis. So maybe this is something you could easily and quickly find, put on your paper to go ahead and show you knew where to go ahead and put it. 1.8. So I'm going to come back over here. Let's say 1.8 is right about here. And then what was my grand mean? 613? So 6, 10, 11, 12, 13. So I put that point right there, and I'm not confident that I can draw a straight line, so I'm going to go ahead and do this. There we go. Okay. All right. Yeah, a problem like that involving a scatter plot, okay, more than likely you are going to be plugging it in on the calculator if they're looking for Pearson's correlation coefficient R. But, I mean, any extra work you put, I don't think it hurts, especially if it's going to show that you are knowledgeable about the particular concept. Does anybody remember the formula that we actually used? Okay. Remember, there were 3 parts to it. We had R is equal to S sub xy over S sub x times S sub y. Now remember, this is one thing they will not be providing you on the formula book. Okay. Does anybody remember what we call S sub xy? Oh, close. Covariance. Okay, that's the covariance. So S sub xy. Okay. It was the sum of the product of x minus the x mean times y minus the y mean, all divided by n. Okay. Do you remember what S sub x and S sub y were? Okay. So tell me that again, sir. So S sub x equals
the sum of the x minus the x over n.
Just one thing. Squared. Okay. One more. There you go. I don't know why I said one more when there was 2 more. It's a Friday. Okay. But remember, what did that give me about the x's? That was standard deviation. There we go. And now the other one, S sub y, was going to be exactly the same. I'm just going to replace the x's. That's a horrible sigma. Y minus y mean over n. There we go. Like I said, you probably won't need that. In fact, I pretty much guarantee you won't need it on the test. They're not going to provide it on the formula booklet. But, maybe if there was one formula that you were absolutely going to go ahead and memorize, it would be this one, just to show, you know exactly what you're talking about. Maybe the grader will be like, hey, so if there's a mistake later in the paper, hey, I'm going to give her points for this. I don't know. Good. Okay. All right. Have we been looking through that first review? Okay. There's several sequences and series problems on there. There's a probability problem. In fact, did anybody see the cumulative frequency problem? Okay, if you got time, go ahead and take a look at it. We're gonna actually start next week looking at that review together. Speaking of this paper right here, that problem I was just referring to with the cumulative frequency, I went ahead and copied this off for you, a little blank grid, so that it's easier for you to go ahead and create that table. Okay, so that's specific. I don't remember what problem it is off the review, but I remember it's for that cumulative frequency problem. Okay, so if you have the opportunity, okay, I mean, we're not going to have any homework this weekend. I know people are going to be sad about that. So, oh, wait, I got a review. Right, Carolina? She got a big smile on her face. She's all, yeah, I'm doing it. Okay, so focus activity 1 is out of the way. Okay. Let's see. Now, we still have the quiz today, but I did want to go ahead and at least get started with the very last lesson. Okay. What we've been doing up to this point, we've been finding the derivative, and even that was progressive. We started with, talking about limits, then we moved on to the difference quotient, the formula, which is on your quiz today. Then we started looking at the power rule, and now we're actually going to be taking that slope and doing something with it. Okay, so I'm thinking we'll probably get away with one problem today, and then we'll go ahead and go on to the quiz. So the derivative of a function, also called the gradient function, can be used to find the slope of a tangent at any point x equals a on the function. So that's what I've been referring to as the difference quotient. Okay. You simply replace x by a in the gradient function f prime of x to obtain the numeric slope at that point on the graph. Now this we've already been doing. Okay, so find the gradient of the tangent to the function f of x equals x squared minus 4 over x. Okay, so let me go ahead and rewrite this first. So f of x equals x squared minus 4x to the negative 1. So now, what is the derivative? F prime of x.
2x.
So 2x plus 4x to the negative 2. Remember, we take the power, we multiply by the coefficient, we subtract 1 from the power. Okay. But now I want to know the gradient to that tangent line at this particular location. So what am I going to do? Just plug it in. So f prime of, we're at x again, 2 is equal to 2x, 2 times 2. And I'm going to go ahead and do this. I'm going to go ahead and put this back in the denominator, plus 4 over x squared. So I'm just going to say 2 squared. So I'm ending up with what? Oh, now 1. Well, now 1 there, but plus the 4. So at that point, when x equals 2 on that graph, we should have a tangent line that has a slope of 5. Okay, so that's nothing new, right? We've seen that before. In fact, you did that on the homework for the power rule. Well, now we're going to go ahead and take it one step further. Okay, find the equation of the tangent line to f of x equals x squared plus 1 at the point 1, 2. So now after I find the slope, I want to go ahead and write the form. Now this one doesn't say what form to write it in. In order to start, let's go ahead and begin with point slope, or I guess I should say point gradient. Does anybody remember what that general form was? Oh, now that's slope intercept or slope gradient.
Is it y minus y1
There we go.
equals m times x minus x?
That's an m times x minus x1. Yes. And then our final answer, we'll go ahead and put that in slope gradient form.
Is that equals m?
Yeah, my m turned out a little weird. There you go. M. All right. So now everything that we just did on the previous problem, we're going to go ahead and do, and then we're just going to take it a step further. So what is the derivative, f prime of x squared plus 1? Okay, well that's easy. Because the derivative of a constant's what? 0. Now, I'm wanting to go ahead and find out the tangent line at the point 1, 2. So what am I going to plug in to find the slope? There you go. Even though they're giving me the point, they're still giving me the value of x, right? Okay, so f prime of 1 would be 2 times 1. Well, that's just 2. And see, now I have everything I need. I've got the point that the tangent line is going to go through, and I have the slope. So that's why I suggested we go ahead and start with point slope, and then we move on to the other one. In fact, using 1, 2, and 2, who can give me this formula? Y minus 2.
Equals 2 times x minus 1.
There we go. So that would be the equation of the tangent line at the point 1, 2. And then from here, it would just be, you know, whatever form they happen to ask for. I'm just going to go ahead and say, let's put it in slope-intercept or slope gradient. So y minus 2 should equal what? 2x what? Okay, well, I'm going to go ahead and minus 2. So we actually end up with just 2x, right? There we go. So that's really all this particular lesson is about. Taking that final step, okay, now that we have the derivative, we have the slope at that point. Let's use the point and the slope to go ahead and write the equation. What's another version they could ask you about? Remember, the top 3 were the point slope, slope intercept, standard. What was standard? AX plus BY is equal to C. Yes. All right. Good. Good, good. All right. Well, I at least wanted to go ahead and get started today. And right now we have right about 20 minutes. I don't think it's going to take you that long. So.